So yesterday we were multiplying and dividing rational expressions. Today we're going to go on to adding and subtracting rational expressions. And one really important thing when we are adding and subtracting fractions is that we need common denominators in order to put those two fractions or more fractions together. So we'll start off with a couple easier examples. So the first thing that you should always check is if you can cancel anything in the individual fractions themselves. So here I don't see anything common. It's y and 6x. And here 2x and 3y, there's nothing common there. So, Martez?
You could do like the across like the 2 and the 6, it could become 1 and 3.
Okay, so can I cross cancel? When am I allowed to cross cancel? Okay, so that is another area for common mistakes that you might see in your questions tomorrow, right? If there's an addition sign, if there's anything other than a multiplication sign, we should not be cross-canceling. You can reduce in the individual fraction itself, but no cross-reducing, okay? So let's think about a common denominator between 3y and 6x. How about 3 and 6? Let's start with that. Common denominator between 3 and 6? 6, right? And each side needs the variable that the other side has. So this one just needs a y, and this one's going to need a 2x. Okay, can I do anything else to reduce here? Am I finished? Can I go further? What do you guys think? Charlie? Do you think we're done? Martez?
Can you reduce the y?
Good question. Can I reduce 1 and 1 out of here? What's right next to the y squared?
Wait, you can do the x then.
Then we can't do that.
You can do the x.
Okay, but what's right next to the x?
Well, it's on the right side.
Doesn't matter. If you have two terms being added, you can't cancel individually out of those terms, okay? So we are done,
That's unfortunate.
okay? With the exception of restrictions.
No, Martez, we're done.
Yeah,
You said we're done, Martez.
Can you
We're done.
simplify the x and y and put it in brackets on the top?
Why would you?
How would you do that?
Like you would take away an x and a y, and it would be like x, y, open bracket, 4x plus y.
No, because there's no common x and y in each term, right? The first term only has x's and the second term only has y's. So we can't common factor. Okay, restrictions. Any variable that's in the denominator at any time needs to be restricted. So x cannot equal, Martez?
0.
0, and y cannot equal? 0. Beautiful. Okay. Okay, so check in each individual fraction to see if you can reduce anything. I think 5x and 6y, they don't share anything common. How about this one? Zach? Yes, so we can reduce an x here. This is perfectly acceptable as long as it's in the same fraction, right? So I'm not going to cross-reduce anything, but I can reduce in an individual fraction just like we do any other fraction. Okay, so now we have 5x over 6y minus 2x over 5. Okay, if you forget to do this, you can certainly common factor at the end, but it's just going to make your life a lot easier if you remember to reduce first and then continue on from there. Okay, so common denominator between 6y and 5, 30y, right? So this side needs a 6y on top and bottom, and this guy needs a 5. Oops. Okay, and then factored form is simplest form, so you guys might notice that they share a common x. So we can actually just common factor an x out from each term. It doesn't help us reduce, but if we're looking for simplest form, we would consider that. Just in case, we always look for that common factor that could maybe be reduced with the denominator. But because we reduced first, We shouldn't have any reducing that's necessary at the end, even after we common factor. Okay,
Y cannot equal 0.
y should not equal 0. Is that it?
Yeah.
Look at the original question.
Oh, cool. X cannot equal 0.
Right.
So, even if after you finish the question, you still have to do the restrictions on like the first part?
Any variable that was in the denominator at any time will have
So like
restrictions.
it's good as we go and we find it.
Yeah, you can
the
start a little
restriction.
list like as soon as
Yeah,
you start,
exactly.
for sure.
Cool.
Any questions on this one, guys? Okay. Let's continue. All right, so I've listed out some steps for you guys with adding and subtracting. As we do with multiplying and dividing, we want to factor and common factor everything first. It allows us to see restrictions more easily. It will allow us to cancel and reduce in the individual fractions if possible. And then it helps us when we go to find common denominators and stuff like that. Okay? So the goal is that we factor everything. We'll start a little restrictions list. And then you need to find a common denominator and merge those things together. And then we'll get to the second part of that. So we're going to start with just factoring everything with our first part here and starting restrictions and then seeing if we can get a common denominator, the first few steps.
X cannot equal -2. Is that what it said? 2 plus 2, yeah.
So we're going to factor everything to start.
But you told us to do restrictions first.
So factor and then restrictions.
Oh.
So for this trinomial on the bottom right, we're looking for two things that multiply to 8 and add to 6. 4 and 2 should work.
Whoa.
Okay, if you want, you can start a little restrictions list at the top or wherever you want. What are our restrictions here?
Well, you put brackets around all of them.
-2 and -4.
You'll see. -2 and -4. Okay, so we've factored, we've done restrictions, those are the first two steps. Take a look at your individual fractions. Can we reduce anything in those fractions before we start? I don't think so, right? Okay, so the idea here is that each side needs what the other side has. So this side has an x plus 2, this side also has an x plus 2, but this one has an x plus 4, and this one doesn't have it. So this side is going to need the x plus 4. That's right, so we'll multiply the bottom and the top by x plus 4. Remember, whatever you do to the bottom, you also have to do to the top here.
So would it be 2 separate? You know what I mean? 2 separate, like x plus 4 and x plus 2, so it'd be like that. Yeah, what you're doing right now.
Mm-hmm.
Okay.
So that's kind of why I bracketed things up on the top. This one you could leave in brackets or not, it doesn't really matter. Okay, and now that we have a common denominator, we can merge these together in one fraction. So don't get confused just because there's different like binomial brackets here that are being multiplied. What we do in like a regular question is once we have a common denominator, we keep the denominator and we kind of like put the numerators together, right? So when I go to find a common denominator here, or when I've done that and I go to put them together, we keep the denominator as it is, right? So it's just x plus 4 times x plus 2, and we kind of put the numerators together. So the numerators will be x plus 4, x minus 2 plus x plus 10. Okay, this, you don't really need brackets around this because I'm just adding, like there's technically a 1 out here. So we could really just drop the brackets on that since it's just two single terms there.
You get rid of x plus 4.
Okay, so Zach brought up something good. He is saying we can cancel here.
We can, right?
Okay, I'm here to tell you that this is a math crime, okay? I know it's not next to a plus or minus, but you need to consider this whole thing as a group. And that group is right next to a plus sign.
Do I get free
Okay.
food in math jail?
You don't get any food in math jail. Okay, so this is something that you just need to be aware of. It's good that we're addressing these things for sure. But in order to cancel, I would have to have all the things on the top being multiplied. As soon as I'm adding something extra on the end there, I can't start canceling pieces of that again. So think of this kind of as a whole grouping. To cancel anything out of that group, it can't have a plus or a minus sign right next to it, okay? So what we need to do is, if you look at your steps here, we're going to expand and simplify the numerator, okay? So at the top here, we're going to FOIL this expression. And we do not need to expand and simplify the denominator because the denominator is in like perfect factored form right now, so that shouldn't be necessary. If I expand it, then I'm just going to have to refactor it again. The numerator is not in perfect factored form right now, so we're going to expand. And we'll gather like terms. So only expanding the numerator, leave the denominator. It's already factored. It's good to go. Okay, now this looks like a nice trinomial that we like to factor. So if possible, we will check if the numerator can be factored or common factored. Always want to ask ourselves that question. So are there any two things that multiply to 2 and add to 3?
Yes. 1 and 2.
Oh, okay. And this is an easy trinomial where a equals 1, so we can just put them right in the brackets. It's x plus 2 times x plus 1. And now we can cancel out x plus 2, that's right, actually, because there's all multiplication happening on the top. So we will cancel that.
There's no stupid plus or minus sign, right?
Exactly. And we're left with x plus 1 over x plus 4. Okay, and then your restrictions that you listed above are also part of your answer. So you can either write that next to your answer or just make sure you have it somewhere kind of boxed up. Okay? Martez? Yep.
Can you?
Okay, so guys, when you do your conversations tomorrow, I will guarantee you some of you will see this mistake that Zach mentioned earlier, where you cancel when there's a plus sign here or a minus sign or something like that.
What mistake did
Okay?
Zach make here? That's gonna be that one.
You pointed out a valuable area that we need to avoid, so it was actually good. Okay, can I clarify any questions here? Once you get the hang of the steps, it's really mostly just factoring and then canceling, right? So if you practice, you'll get the hang of them. Okay, let's try another one. Okay, so every single question, multiply, divide, add, subtract, factor and common factor, numerators and denominators. We're going to start with that. Okay, so bottom left, two things that multiply to negative 48 and add to 2.
Big.
Okay, what combination of 8 and 6 works for this?
Come on, guys.
Negative 6 and positive 8. Want to add to positive 2.
Oh my god.
Okay, and multiplies to negative 30, adds to negative 1. Looking at this guy now.
No, negative 5 and 6.
Okay, what combination of 5 and 6?
Negative 6.
Negative 6 and 5.
Okay, perfect. Okay, I also usually just like to kind of bracket up the numerators just to show that those things are like groups together.
Do we do restrictions?
Yes, we will do restrictions. So start yourself a little list. X cannot equal, Lauren?
6,
Lovely.
She didn't say all of them.
I said it.
She was confident. She just wanted to go for it.
You asked me, right?
Yeah, you could do them. Okay. Before you guys go and get common denominators here, look in the individual fractions. Can we reduce any groupings out of those individual fractions? Is there anything common on top and bottom? Okay, so common denominator then. Each side needs what the other side has. So they each have right now an x minus 6. What does the fraction on your left need? It needs an x plus 5 on top and bottom. And what does the fraction on the right need?
X plus 8.
An x plus 8.
Some X water, right?
Okay, so I am going to merge these together into one single fraction here. Keep in mind that there's a minus sign in between, so that minus sign kind of goes in between your two numerator terms there when you merge them. Okay, guys, when you have this, don't go cancel crazy, okay? When you have this, it means that this is kind of like a grouping, and this is a grouping, and we can't cancel anything from individual groups like that. So you cannot start canceling, okay? You need to first expand and simplify the numerator, okay? So we are going to FOIL each bracket here. Hi, Abby. Okay, so x squared plus 9x plus 5x plus 45. Here's a little just thing to note. When you have a subtraction in between, when I FOIL out the second bracket, I'm actually going to leave it in brackets because the minus, this minus sign actually applies to every term in this expansion here. So leave your second expansion in brackets. The negative must go into everything there after you do that. Okay, so it'll be x squared plus 8x minus 9x minus 72. Okay, don't expand the denominator. That's just going to be a headache for you, and it's already fully factored, so you don't need to expand the denominator. Okay, so this is the reason we left this in brackets, because this negative actually applies to every term here. Okay, I'm gathering up the 9x and the 5x to get 14x here. I don't necessarily need to see every single one of these steps. Like if you feel like you can do like a couple things at once without having to show it all. But it's always good for checking your work if you kind of show your steps. That way if you're looking back through, you can see if you made any mistakes. Okay, we're almost there. We're just going to gather any like terms. So x squared and negative x squared, those cancel each other. And then we're going to have 14x and negative 8x and 9x. That's going to give us 15x. And then 45 and 72, I think that gives us 117. There's a positive x squared and a negative x squared, so those are gone. Okay, once you've expanded and simplified the numerator, you always want to ask yourself, can I factor or even common factor the numerator? That is the question. So if this isn't like a quadratic, so this right here, it's linear, right? So it just has a single x in it. I can't factor it, but I could potentially common factor it. Is there anything common between 15 and 117?
Yeah, 3.
Okay, so 3 we can common factor out, so we'll be left with 5x and 39. And you can always check at the end, now that we have everything in fully factored and common factored form, check to see if you can cancel any brackets. So do we have anything that can be canceled? Okay, so this is just now in fully simplified form, and along with those restrictions from the top. So we said x could not be -5, 6, or -8. Okay, this is how you're going to do all of the addition and subtraction questions, okay? So once you start practicing, you'll kind of start getting the hang of it and what you can cancel and what you can't cancel. Okay, last question. Do you guys want to get started on this one and then we'll take up some of it? Or do you want to do it together?
I don't have enough room to do this question.
Do you want to do it together? Okay, last one together. Okay, factor and common factor everything. So let's start with top left. Can we factor this? Ooh, it's a difference of squares. So 5x plus 6, 5x minus 6. Lovely. Bottom left. So this is a trinomial when a is not equal to 1. Okay, I'm not going to show you guys the whole factoring process for this. I'm just going to get it factored. We're going to get 5x minus 6 and x plus 1. Okay, I trust that you can factor a trinomial now. Okay, x squared minus 16, what does this factor into? Sheila?
X plus 4 and x minus 4.
Very nice. Difference of squares again. And trinomial, easy trinomial on the bottom right.
1 and 3.
1 and 3 works.
Wait, no, why say 4 first?
I thought I heard someone say 3.
Nice.
Okay, Zach, what are we going to do now?
We're gonna do stuff to it. Are we able to cancel? Oh, restriction.
Restrictions.
-3, -1.
What do we get from this?
Some other number for that one.
So remember, yes, so switch the sign and then it's right over the left. You'll get a fraction from that one. So it'll be positive 6 over 5.
Wait, why is it a fraction?
So what makes 5x minus 6 equal to 0? Well, if I solve for the x that makes that equal to 0, we divide out the 5 and we get 6 over 5. That's where that comes from. So if you ever forget the little shortcut, you set it equal to 0, solve for the x that makes that happen, that's your restriction.
Oh.
Because we don't want it to be 0, right?
Oh, yeah, so-
Okay. Here is one question where the step before we find the common denominator is very important. Look in your individual fractions. Can you cancel anything out, Charlie?
5x minus 6.
Yes, so I can actually reduce first, as long as it's in the same fraction. See how this fraction is completely like term being multiplied and multiplied? So I can cancel, that's okay there. And then, that's really nice because now I don't have to deal with crazy numbers on the top. If you didn't do that step, you would make your life,
Do we always have to put
difficult.
brackets around it? Like
you don't have to, but we're going to be multiplying it by something anyways.
I know,
So
but just like if you're not just in that.
if it's just like a single, like if it's just like 2 terms and you're not doing anything, you can leave it without a bracket for sure. Okay, so now each side needs what the other side has. So they each have an x plus 1, but the one on the right has an x plus 3. The one on the left needs that. So we'll put that in. Okay, and then we cancel the x plus 3's, right?
No,
No, you can't because it's
Why
a
not?
fraction sign.
minus
Okay, so that's a no-no, right? All right, so what do I do then? Okay, we will expand and simplify the numerator. This one, just as a little hint, this one is actually x squared minus 16. We did factor it, and now we're kind of like foiling it out so we can gather it with these terms here. But yeah, it's going to FOIL out into x squared minus 16. The only reason we did that is so that we could check if maybe something in this fraction could be canceled, potentially. So I'm just going to write that as x squared plus or minus 16 there. Remember, we keep that second part in brackets
Because we're doing rounded subtraction.
because the negative goes into both of them, right? Okay. So first brackets here. So this is the one really crucial difference between the addition questions and the subtraction questions. They follow the exact same process, except for with subtraction, you have to do this extra step of bringing in the negative into that second part. You don't have to do that with addition, of course, because when you're adding, it's just like bringing in a positive 1. So that will remain unchanged. But with subtraction, that is very important that you remember to do that distribution of the negative. Okay, we're almost there. We're going to gather like terms on the top. So we have 4x squared plus 21x plus, what is that, 34? Okay, and then the last thing that we would want to ask ourselves is, can we factor or common factor this here? So you would be basically looking for two things that multiply to 136 and add to 21. You can try to divide out a couple things. If things are adding to 21, I'd maybe go like, I don't know, you can try to divide like 136 by 6 to start. And then see if you're going to get, 136 isn't divisible by 6. So we've got like 2 and 68. It's divisible by 4. 4 and 34. I'm not getting 21 there. 17 and 8. That's not going to get me 21. I'm getting closer to a combination that would maybe work. But I don't think we're going to get really anything that works for that. So you can try a couple things, but this one I would say I don't think it's factorable. 17 and 8 is the closest combination that I can get to equaling 21, and that's not gonna get us there. So this would be a no, and that's totally fine. You're just done at that point, okay? And we have our restrictions from above, so -3, -1, and 6 over 5. Lauren,
Use decimals or no? If you-
for factoring?
Yeah.
No, we don't use decimals, no. That doesn't mean that this necessarily doesn't have like x-intercepts or whatever. Like we know we can use quadratic formula when we have that like decimal scenario, but in our case it's not going to help us simplify any further, right? So, and it would probably take a really long time for us to find decimals that work, right? So, yeah.
I mean, you can do it if you really want to.
Okay.